So we will start with a new drawing. And we will create from scratch. So remember, you can go to the start menu, choose a template. We're choosing the millimeter template for mechanical, and then you can click new drawing. If you need some help with the intermediate steps, you can find them in 24/7, Brictis 24/7. You have the sheet metal from scratch, and there you have some steps. So we will also need the 2D holes later on. So make sure that you know where this is located on your computer. Like Frederick already explained in the previous sessions, through the cloud pod or the cloud download pod or something like that. So the first thing we will do is draw a rectangle. You can go to the sketch tab for that, for example, or you could launch it in the draw tab from the quad. Then you can specify the first corner by typing it in, such as 0, 0, 0, or you could click somewhere in the drawing if you don't want it exactly to be started in 0, 0, 0. But I suggest you start it there by typing in the values. And then you can either type in 100 and 255 in the dynamic dimensions by you can cycle by pressing tab, or you can just type in the value 255, 100 and 0 for the second point. So that's also an option. Then we have a rectangle, and we will create a flange from this. So we will actually create a sheet metal part from scratch, and we will use the flange approach. So to turn this polyline into a flange with the sheet metal sheet metal option in the quad. You create the base flange, this one, and then it will automatically take a standard setting for the thickness of sheet metal, but know that we will be able to change this afterwards, and we will also try this out. So don't worry about the thickness just now. And we accept with enter. You see that it turns a sort of blue. All our sheet metal parts have different colors. They are automatically colored whenever they are valid or converted into sheet metal, and you can use the sheet metal functionality on them. So the next thing we will do is from this bottom edge, you will create a flange, but for that you need to make sure that here in the top your edge detection is on, and because we will use it later on, we will also already put on the prioritization of faces. But if you hover now on an edge, you will see that the solid edge option displays. If you hover over the solid face option displays. That's because we prioritize those right now, so we don't have to press Control to get them. So we hover over the bottom edge towards us, and we will make an extra flange there. And why do we select the bottom one? Because we want to have a flange that goes towards the bottom and not upwards. So if we would want to create a flange pointing upwards, we would select the top edge. If we want to go down, we select the down edge. So that's what we do. And then we create the flange edge, create flange from edge. And then you see that if you move your mouse in the bottom half of the screen, you can type in a value of 13. And then again, you step to go to the angle and choose 90 there, or you could hold down shift while clicking in a downwards direction. But I find it a little bit easier to toggle in the values. And then we accept by pressing enter. And then you see the band is colored yellow. As I said, we have special colors for sheet metal. And then we're gonna do the same for the back edge, but now we are gonna make sure that we use a sub option here to control the width of the flange. So we don't want the flange like this to go over the entire length of our part, but we want it to go 32 millimeters inwards from both sides. So for that, we type in W, or we choose the width option from if your command line is open, you can click on that. And then you see that now I can push away the flange, and you can do that by 32 millimeters. Then we will get the same option for the other side, again 32. And then we enter back in what we had previously as well, the way to specify this is to type in the 62 millimeters, so 62, and we type in 90 for the angle so that it is orthogonal, and then we press enter. And you see that here there is even an extra spare place, I don't know how you call that, cutout made so that this can be easily bent later on whenever we would produce this as actual sheet metal parts. So now we can also do the same thing. It's a bit of repetition towards the back. So remember to select the edge in the direction which you want to create the flange in. Then we will again make this one 13 and 90 degrees angle. So that's that. You can also find this in step 6 of the training manual. Then we can show the mechanical browser now, and we see that we have all these different parts which we created. Actually, so the reliefs, that was the word that I was searching for here, the cutouts. They are all listed in the mechanical browser, and you can see their thickness and so on. And if you press the entire heading drawing 1, you will see that you have even more options, such as here the entire thickness of this entire part. If we change that, make sure that you're zoomed in enough so that you can see the change in thickness. So we can change this thickness, for example, to 5, and then you see the entire part becomes thicker, yet the overall dimensions are maintained. So turn this back to 2. And then you can also play with the bend ratio or radius ratio. Yeah. And that's here by clicking the plus in front of the, the plus in front of the bend radius. You will see that there is a type and a ratio. So now we're making a ratio as opposed to the thickness of the part. So the ratio 3 means that we have less sharp turns, let's say. But we can change also this back to 1, I believe, or no, we leave this at 3, sorry. No, we undo the change. So yeah, we just set this back to 1. It was just to show you that the overall dimensions, they keep being maintained even if you change the band. Then we can hover also, we can try to hover over this front face of the flange, and then we can, in the sheet metal tab, use or in the sheet metal tab, I think, use the Flange rotate tool that I now that I just looked over. So it's the one with the little arrow, and you can press that one, and then you can actually see that even with these with another bend, it will still try to keep your intention intact, let's say, and it will try to remain like you wish, but you don't have to accept it. You can just press escape, and then or you can do it and then undo. And that's that for this part. Then we can also try yet another manipulation to the sheet metal, which is push pulling of this phase. So in the model tab, you will have push pull. And there you can see that if it's sheet metal, you will be able to quite nicely adjust the position of the flange, and the thickness of the sheet metal will be maintained. So it acts differently than a regular push-pull, and I'm going to demonstrate this now. So you can try to, in the sheet metal tab here above, you can try to dissolve this entire part. What does it mean? It means that you make it a regular solid again, actually. So you see the color changes. And if you now try push-pull, you will see that it acts way differently. The thickness of your sheet metal part is not maintained, is not recognized as being a fixed thickness. So that's how it changes. But we will undo this step and we will go back to here, the sheet metal. You also saw that whenever I dissolved it, actually all the features went away, or all the flanges and reliefs and so on, because it turned back into a normal solid. So now we will continue with creating some extra flanges, but this time we will use, we will do it with 2 at a time. So we select here the lower edge and at the other side as well. And then you want to create a flange, but this time if I zoom out, you will see that I'm simultaneously doing 2 flanges at once. And we can create a length of 66 and a radius of 90 again. So you can use the tab, or you can hold down shift or be in the ortho mode to realize this. And then we accept that. And you see that all these, this part gets entirely color coded. So here are some reliefs already for the corner as well. And if you looked at it, it was not before, so it made it automatically. So let me just redo that step. So select both bottom parts, select given the distance and the angle. And then you see that here these reliefs are automatically created. Then the last part is the second to last flanges that we are going to create are these two. So going outwards, again, we select 2 at the same time. As long as you want to go in the same, as long as you want it to be the same length, this is possible. And then we key in the values 15 and 90. And you see again, some reliefs are created here in the back. And lastly, we add some small flanges here at the bottom. It's a bit of repetition to get you familiar with creating these flanges. And that is 15. and 90. And I think I made a mistake. And these flanges should be, should be 25. So yeah, now it's it was the 15 that we had. So you could still push pull this part with 10, for example, to give it a length of 25 anyways. But yeah, note that it's not too important, but that I did say the wrong value there. So in the training manual, it's correct. And also here, the reliefs were created. So now we are at step 16, and we are gonna add some holes to this part by going through the library. If you go to the home icon, you will see that we have a category holes. If you would not see that, but I doubt that, you want to make sure that in the three stripes here at the top, you have the Brixis mechanical checked on. And then you can go to the holes, and you can use a regular slot. And upon insertion, you will get an opening. Your properties panel will open, and you can change the diameter to 5 so that it becomes thinner, and the length to 40 so that it becomes longer. And now we are gonna hover back over our drawing, and we're gonna hover over the face in which we want to insert it, namely this one. We are gonna shift lock it by pressing shift once. You see that it's rotated wrong. I want the slot to be in the same direction as my flange. So I can type in R, or I can press rotate component. And then you will need to give in an angle. Either you visually give in the angle and you can hold down shift, or you just type 90 so that it's 90 degrees tilted. And then when you're inserting, you will see that you can specify from the side and from the top. It is placed 30 millimeters. 30 millimeters from the top. So remember, tap to cycle through everything, and 12 millimeters from the side so that it's approximately in the center. I think my dimensions are not entirely correct, but it's the main idea that counts here. And then we accept it. And now we can, we have actually created a hole. If we would go and we would hide the basis subtract layer again, it is clearly a hole. But I also want it to be at the other side. So what I can do is mirror it, either with the manipulator or with just the regular mirror tool. But with the manipulator, you can you should place the manipulator first on a different location. That's easiest. So you can use the wide grip to place it on a different location, for example, the middle here in front. And then you can use the blue arrows to mirror things with the manipulator. And since we moved the point of mirroring to the middle, actually we need to mirror it over a value of 0. So we type in 0 then. And you see that now it's mirrored, but the previous one was deleted. So what you can do while you are mirroring, so we can mirror again to the other side now. You can press C or press here the sub option copy, and then do the same thing as I did before, given a value of 0. Press tab to enter. Oh, press. Will escape once. Okay, it was already made. Sorry, didn't see that one. Not sure. It was only once. And that's how you can mirror with manipulator. But of course, you can also use the regular mirror command and choose a plane in which you want to mirror, and choose the appropriate midpoints. But I guess most of you know how to do that, so I won't show that. And now we can switch off the basis subtract layer because we don't need it anymore. Oops, rotating sidewardly. Okay. And now we need to select a few edges because we want to chamfer them. Namely, we want to select this small edge here, this one at the top here, this one at the back here, and then the same locations at the different side. You can do them all in ones, or you could do them one by one, but I like to do them all in one go. So I just click them because they are very particular areas where I want to chamfer. So it's easiest to manually select them. And then you see that we have 6 highlighted edges. We can right click an empty space to get out the quad, even if you don't hover over another element. And then in the model tab, you can use chamfer. Also notice that there are now a lot of different chamfer options that we haven't touched upon yet, but that can help you make asymmetrical chamfers, for example. But for now, we will use the regular chamfer tool. And then if we zoom in a bit, and yeah, the preview is a bit hard to see because it's actually the small kind of values that you need to have. So you can use the ruler to go to the small values. Or you could just type in 5 and you will see it coming, it becoming good anyway afterwards. So here you see that now the corners are chamfered like we wanted. And now we can do the same thing for these big corners, but instead of 5, we use 50 millimeter. And then we have created a new shape. And now the step 21 asks us to add the 2D holes, to insert the 2D holes drawing into this drawing to, because we have a standard layout of holes that we want to get into this part. We can reuse that from another drawing. So we can call the insert command. The regular insert command is good for this one. So I typed in the command, but you can probably find it somewhere in the ribbons as well. And what we do is we browse to the, oh, no, that was not what I wanted to do. I want to go upwards to the mechanical training folder that you have, to the V21, and then the sheet metal from scratch. And then you see the holes to the DWG. Well, it's that one that we need. So we open it. And then here you need to check specify on screen, because we want to specify on our screens where we want to place it. We just don't know if it's the correct location otherwise. In this case, because it's not a fixed to, yeah, it's just something which we need to lay over our part. So we need to specify it on screen. And we want to explode it right away because otherwise it will be inserted as a block. But if you check the explode option while inserting, it will be automatically as if it was in the original drawing. So then we press OK. And now you see at my cursor, there are these holes. And we can just hover over our top face with the dynamic UCS on. Remember that here at the bottom. And then you can snap to near the endpoint so that it's correctly located. And that concludes step 21. No, not yet. Actually, it almost concludes it. The only thing we need to do is select all these holes. You can make a selection box. It's the easiest way to get there. A blue selection box, so from left to right, which doesn't include your sheet metal entirely, so that you can have only the holes selected. And then you can use the solid extrude from the model tab in the quad. And you can extrude it downwards, doesn't matter with how much, because in the first mode of extrusion, it will create a hole actually in these elements, right? And now the last part for this exercise, and also the main exercise to focus on during the breakout rooms, is the unfolding. So we hover over the top face and we choose to unfold it. Unfold that part with the little star at the top. And then you will see that your unfolded part is at your cursor. And what you can do is you can click a location, and then you still need to press enter to keep the unfolded body there. So that's it. And then you can see that all the holes are transferred to this unfolded part. The radii are given together with the overall volume of your part to give you, to let you know how much space you need on, or how much plate you need to cut out this part. And that's it for sheet metal from scratch. And then I will quickly show the sheet metal from solids as well, I believe. Just let me check out if that was intended. Yes. So remember that this is an extra exercise and you don't have to do it, but it's explained quite well in the handouts. So what I can do is open a new drawing, and I will now create a rectangle. So we can go to a box. So I can go to the solid tab, choose the primitive box. I can start from 0, 0, 0 by typing it in. And I see that I have already the values for the second point. So I just type them in. Make sure there is no at in front of the values you type in. Otherwise, it's a relative distance to that part. Well, I think in this case, it's the same because we started at 0, 0. But if you want, like, that's the distinction, is that if there is an at in front of it, it's relative to your previous location, so to speak, or your previous point that you keyed in. So that's it. And then we have the box. We can again use chamfer. You probably know this by now, this time with 50. And then we can extrude the face. The first option here will be uniting, so that's good. And we can extrude it by 50 as well. Then we can rotate this face with DM rotate from the model tab. Make sure to get this where you now see the blue line, to get this axis as axis around which you want to orbit, and then you want to orbit it 15 degrees downwards. Okay. And then we can shell this. Shelling is very interesting when working with sheet metal, because you can actually make sure that it has a constant thickness overall. The easiest way to do this is hover over your bottom face and go to the model tab and select shell. And only this face will be excluded. So the faces from which you started will be excluded from the shell. And you can enter a distance of 2 millimeters, for the thickness of your sheet metal part. Then what we will use now is the offset command. you can always hover over a face, and in the Draw tab, you will have the option Offset. So you can actually offset all the boundaries of this face. While they keep being connected, you don't see it that well yet. But if I enter a value of 10, you will see that now I have this rectangle here. And then I want to extrude this rectangle behind. You only need a thickness of 2 millimeters, but you can also give it a little more value to subtract these from the top part. This is actually the top part of a machine, of an operating machine. And then what we are almost finished. Well, it's at least the only thing we need to do now is convert it into sheet metals still. So we select this part, we go to the sheet metal tab, and we say, where are you? Here, convert to sheet metal. Then it will turn blue, but actually if you would try to unfold it, it would not work because there are no bends in it or anything yet. So the first thing you can do is create the reliefs. So I can actually select here in the Modify tab the relief, or I don't know how you actually pronounce it, but okay. Then you can choose the entire model, for example, and you see that all these little reliefs are created. That's one way to go. On the other hand, if you use the other tools, such as bands and junctions, these will often be created automatically. So what we can do now is we can create junctions, and we do that by launching the junction command, and then selecting these edges here, and you see that they turn orange and they get separated. The reliefs, they go away because they're actually not needed anymore. So that automatically happens, except at the back, because there it's not split yet. Okay, so then we accept. Oh, sorry, that was wrong. Can I undo? Okay. Yes, apparently I can, but if I exited the command, you can still undo some steps if you accidentally created too much. So here I still see that I undo one step too many. So that you shouldn't press the enter button because it will accept it. It will see it as if it's the whole model. You should press the enter button, I think. So yeah. In any case, you will figure out because you can try a bit and see how this junction works. So that's it. And then we want to create this part. We want to create bends from it. And we actually want to do that on all the different hard edges that are left in our model. So all these that are not bended and that can actually not be manufactured. So what we do for that is we go back to the sheet metal and we choose bend, and we select here in the options entire model. And then we enter, or no, not enter again, exit by pressing escape. That's what you need to do. So press escape to exit the command, because otherwise you will keep continuing trying to make bends. And that's it for the bends. And now we can actually already unfold the part by hovering over any face, for example, going to the sheet metal tab and pressing unfold. And then you see we lose quite some money, not money. I don't know why I said money, but we lose quite some place. That was what I said, and maybe also money if you look at that sense, because you lose a lot of room in the middle where you have just rest material, and it isn't used properly. So that's why we could also split differently our part. There is a note in step 15 if you're using older versions of BricsCAD. I don't need it, but it's for when this junction is not created properly. You can do some extra step. And but in the recent versions of BricsCAD, that happens automatically. And then I will show you the band create tool. It also works on junctions, so it doesn't work on just your hard edges. You can also select the junction face, and you can go to the sheet metal tab and use the curved icon with the blue middle part, which is the bend. And then you can select that one and you can create a bend here. Notice that the relief is made automatically. And we can do the same for this part here. So that we actually will split it differently. And what we need to do for this to be unfoldable is to split this here according to all these diagonal parts. And how we can easily do that is using split, smart split or smart split propagate. Smart split, you will need to press 4 times before you can split all these 4 different corners. Smart split propagate will actually allow you to split one part and then see where other parts are, where this can be repeated. So you just select a vertex on the flange that you want to split. So for example, this one here, and then you see that these lines are given to you, and you can toggle them on or off certain parts. But I will just accept all of them. And then you see that now it is actually split, and you get like a small distance between the two even, so that it can be bended easily. And then you can, as last step of this exercise, and then we will move to the breakout rooms, you can see how the unfolding acts right now. So actually you will see if we unfold that now we have 2 parts. So you can unfold one of the parts and then the other part. And you see that we actually use way less material because we don't need to have a hole in the middle there. So that's it. And then I will leave you to the breakout rooms. And remember that you focus on the first exercise, and the second exercise, you can do it whenever you have time, being it in this breakout room or the next one, maybe even. So that's it, and see you in the breakout rooms.